Hello everyone, and welcome to my containerization proof of concept. Today we're going to be creating a Flask web server using Python. It's very basic. It's only going to be there to serve as an application that we can then prove is accessible via the browser. I have the repository right here. Looking inside the app, we've got app.py. It's seriously 7 lines of code. We're keeping it bare bones. Let me pull up VSC and show you guys. So we have a Docker file here that's going to be running our containers, and here we actually have the app. So let's run it real quick. Now you see that it didn't actually do anything. So what we need to do is use Flask. We can actually go to the Docker file to find the whole command. Flask run -- host equals 0.0.0.0. And so when we execute this, failed to find. Okay, so we need to move into the app folder and then execute that. So here we go. If we click on that and we go ahead and open, so both of these map out to the actual application, which echoes out hello world in the browser. Very basic stuff, but you can see that these are different IP addresses. That's going to become important later on. What we're going to be doing is not just creating these within a container, we're going to be creating these within an Ubuntu VM, virtual machine. Because Ubuntu command line interface is going to be kind of the standard when it comes to cloud applications, I'm going to be going in and creating an Ubuntu VM and then working with the command line to execute this web server within a container to show that it's going to be incredibly streamlined when it comes to switching over to something like an AWS EC2 instance, for example. Now the way I'm going to be running my Ubuntu virtual machine is via VirtualBox, and I have that pulled up right here. If you want to download it and install it, you can go ahead and head to this URL. So pulling that up, we have a few already that I've been using for different things, and we're going to be creating a brand new one from the ground up. So we're going to create a new one. This is going to be Ubuntu Container Demo. It's going to be a Linux machine, and we'll go with 64-bit Ubuntu. I like to give it a little bit more than it necessarily needs, so we're going to do 4,000 megabytes, create a new virtual disk, and let's give it 40 gigs. Why not? Now that it's been created, we can start it up. Now, it's going to create the kernel for us, but here, let me pull this up. I actually don't. So this is what pops up. Select Startup Disk. We need a distribution, a .iso file, in order to use as if we're simulating like a hard disk or a USB drive to run this up. So we can head on over to releases.ubuntu.com. I like 22.04. Especially .1. I was having issues with 22.04.4 because it kept having problems with the boot up. So this version here is much more stable, and I've used it successfully. So I can navigate, once I download that, I navigate to that using this little tool right here, and we select it, 22.04.1. We're going to start the installation. Let me pull the actual virtual machine up here so you guys can see it. Try or install Ubuntu, press enter. This might take a little while, but I want to show you guys the entire process here, so bear with me. And there we go. We've got the jammy jellyfish, kind of a cool background. That's not what we're really after here. We just want to use the Ubuntu command line interface. And that's where we're going to be actually executing and managing everything. Cute little jingle. We're going to install Ubuntu. English is fine. We don't want anything extra. That should be all good. Okay, erase everything on the disk. There's nothing on this disk because it's a virtual machine, so go ahead. We don't need to save any files. We've got nothing to lose in here. We'll just go ahead and use New York. My name is going to be Chris, and since this is a throwaway instance, I'm going to make a very boring password. we will log in automatically and continue. Okay, so now it's actually beginning the install of the distro. This is probably going to take a little bit to pull off. Alright, looks like it's finally finished. We can go ahead and restart it. Now normally I would modify the display settings so that I can maximize the screen and have it adjust accordingly, but for some reason Ubuntu 22 doesn't really like having its display stuff manually overridden or modified or any of that, so I haven't been able to figure out how to make that work. I'm just gonna have to go with a rather sad resolution, but that's going to be okay because the point of this is not to show what the desktop can do. It's to work within the Ubuntu command line. So let's actually quickly scale this up a little bit. Going to be kind of blurry. We don't want to send system info. Quickly, got a finish setup here, and then we can move over to the actual container deployment. We'll wait. It should be fine. Help improve Ubuntu. We don't want to give it location, and we don't need any of that software. So, excellent. Let's open up files real quick, and we will just open this in the terminal, and we want to move the terminal all the way up here so that it's in the favorites bar. What we need, we kind of need the file system, but we're after the terminal and the browser. Browser is going to be incredibly important. Let's actually go back here. So, heading back to my main machine, I've created a Google Doc that compiles all of the resources I use to collect information about how to set this up and links to them, and then I also move the commands in here. But I'm going to be going into the documentation and showing you which ones are valid and where their expertise kind of ends. But we need to be able to access that. So I'm going to log into my Google Drive really quickly. Unfortunately, the clipboard doesn't transfer over from my Windows 11 machine to this virtual machine. This is the resource document that I've used to do this multiple times. I think I'm on my 9th VM right now. But the first thing we need to do, now that we've got the terminal open, we're going to change the network timeout, make it 100 seconds. It's kind of helpful sometimes. It's rather annoying when it does timeout and interrupt you in the middle of something. But we can just copy all of this and paste it in. That kind of defeats the point of including the documentation. So if you want to find the documentation on how to install Docker, you can head over to docs.docker.com, engine install Ubuntu, and it's going to give you a list of all the commands. Here's how you uninstall old versions, and we can do these commands in order to start the installation process. Connecting, it's going to do some loading. We can copy these. If we go all the way over, copy. Now it's going to be a little bit of a hassle installing all of this because it's not the most speedy thing in the world. It's not quite like downloading a little Python module, but it is relatively streamlined for what we're actually accomplishing here. So we got to quickly approve and allow it to do everything. Installing Podman is significantly easier since it's supported by Ubuntu versions 20.10 and up. So now we can paste in the next set of commands. That looks like it didn't even have to reach to an external site. Copy that. Paste it in. Once again, pretty quickly. So now we can install Docker Engine. While Docker Desktop is a great way to play around with things from the command line, all we need is Docker Engine. So it's going to be different and much lighter weight in some ways. I'm actually not 100% certain what the major differences are, but Docker is more functional, and I believe Desktop is intended slightly more for educational and development testing purposes and all of that stuff. But I prefer working with whatever I'm going to be working with in the end, so we'll just stick to Docker from the command line. let's get our next command ready while we wait. So we don't want to install a specific version. We just want to make sure that it works. So now that we verify that it's installed, once it's done, we're likely going to run into an error with this next command. Okay, paste. Unable to find hello world latest locally. Okay, so that's where the expertise from this particular resource ends. Let's head on back to my little Google Doc. Before we do any of that, let's try Docker login. So we're going to use my personal account here and type in my password, and got permission denied while trying to connect to the Docker daemon socket. This is the error we're trying to sidestep, and this resource has a few different suggestions of commands that we can use to bypass it. The commands that worked for me are as follows. So I'm going to copy them, paste them in, and we have to delete the variable, of course, and replace it with my actual username. So now we're in a new group. We can head on back and try Docker login. Okay, so I'm going to use my account one more time. So now we have login successful, and what we want to do is run the hello world image, but we have to pull it first. So let's actually execute both of these commands. First we're going to pull it, and then we're going to run it all at once. So it'll execute those commands in turn. After we get that proof of concept running, just to show that Docker's installed correctly, we can go ahead and get our Flask server pulled into a local repository and execute that so it can be accessed through the browser on this virtual machine. But first we got to verify the installation of Docker before we start trying to do crazy things with Docker. Okay, so as you can see, we got this hello from Docker. I'm just going to run the hello world application one more time so we can see quite clearly. To generate this message, the Docker did these things. So Docker's working. That's good. That means we can go ahead and get our project up and set up on the local machine so that we can execute it. So we need to install Git, which is a version control software I strongly recommend. Git interfaces nicely with GitHub and several other version control cloud services. I like to think of it as the Linux kernel of version control. It's kind of the root of it all that everything else is built on. So we can see Git version 2.34, it doesn't matter. It's installed and it works. So now we need to go ahead and let's see where we are. We're in the home, so let's make a directory and call it _Docker, and then we'll head on in there. And then from here, we're going to make a directory that's called Flask, because that's what our application is. It's Flask. So in here, we need to use git init. It's going to create a repository. And now, if we head all the way up here, this is going to be my GitHub repository for the basic Flask server I showed you in Visual Studio Code earlier. So we need to do git remote add origin, and then we paste in the URL of that repository. Click enter, git pull origin main. It's going to take a little bit to download that, but that's going to include our Docker file and our source code so that we can actually set up the container with a single command, and all of the settings are in the Docker file, which is really convenient. So let's just do ls. We've got our app folder, our Docker file, and our requirements.txt. I'm just going to quickly cat out the Docker file so you can see what's inside it. We're going to install Python. We're going to upgrade pip. We're going to download some things from the requirements.txt, and then we're going to expose port 5000 using TCP and run the Flask command to start the actual Flask web server, which is the same command I showed you guys in VSC at the start of this video. So now that we have our local project, let's go ahead and scroll back down to here. We need to build the image using this command. So it's going to be docker build period for the local directory, and then T is going to be for the tag. So let's just call this Flask Docker server. Flask Docker server. It's done now, so we can go ahead and paste docker run -it -p. So we need to do Flask Docker server. I believe that's right. Let's go ahead and run it. Okay, so let's open up this one first. Unable to connect. The reason for that is because the container, this is the local host for the container. So if we were to go into the container and then run a browser, we could access it through this IP. But within this configuration, we've actually mapped those ports together, 5,000 to 5,000, so we can access it through the IP on the virtual machine that's hosting the container. A little bit of a, protocol bypass sort of thing. It's not like it doesn't violate any security configurations. We're just connecting these two machines in the right order so that they can actually talk to each other. And you can see we have Hello World in our browser. So our Flask web server is working properly. We can close these, head on back here, and exit out of it. So now that we've shown that the Docker container can run Flask properly, let's do the same thing with Podman and see the difference. So we need to go ahead and these are the 3 commands necessary for installation. We're going to paste all 3 of them. So first thing, we super user do apt update, like everything. Then we install Podman and we check the version. So it's going to do all those things automatically. So now we can go ahead and Podman build T. We're going to do Flask Podman server. That's what we're going to call the image. So it has to, again, install Python in its environment and everything. It's handling everything as it should, line by line from the Docker file. Okay, and the rest of the commands went pretty smoothly. We're going to paste this in. So instead of using a capital P to automatically map ports, we have to use a lowercase p and then specify the ports we're using. But honestly, not a huge problem. Flask Podman server. Now, interesting note about this, if we click on this one, we can see it. And if we head over here, we can also see it, which is rather interesting because of the way that the ports have mapped out. Now, if I'm not mistaken, we can also see it from localhost 5000. Let's double check. Yeah, there we go. So with Podman, we can see it using the ports that are designed for the container image or the host image, or not the host image, the host operating system, and we can just go to localhost as well. So even though it requires a little bit more specificity in order to get up and running, it offers different approaches when it comes to how to interface with something. And we might even be able to get away with excluding this altogether and just accessing it directly from the host OS. So that would protect the container even more as far as passing tags in and out goes. But we can go ahead and cancel this, close out of our terminal, exit out of our browser, because that is going to be it for this demo. So hopefully that shows a little bit of knowledge and expertise when it comes to installing containers and running them through the Ubuntu command line, as well as converting an existing Docker project over to Podman with little to no variation in performance whatsoever. So hopefully you learned something or found it interesting, and as always, thanks for watching.